Hello and welcome, dear friends. There are many useful tools in Unity that are easy to miss. In this video I'm going to talk about one of those tools called Scriptable Objects. Scriptable objects can make the process of creating a game much easier. We're gonna create a very simple scene where a player will be able to pick a hero and send a hero into battle. When picking an object, a player will see its attributes such as max and current health, and if a player clicks on the fight button, Unity will load another scene. On the scene loaded, we'll see a hero chosen by a player. Having taken some damage, a hero shamefully runs to the previous scene, and we'll find out whether the received damage will be displayed correctly. This is definitely not a story about a brave warrior, however, this kind of task is quite common in game development, so hopefully this video will be very helpful. I'm not going to use singletons, player's prefs or prefab to store a player's choice. I'm gonna use scriptable objects. If you find something useful in this video, please don't forget to subscribe to my channel. This will inspire me to add more interesting content. There is a turn-based game development tutorial on Udemy. The discount coupon is in the description for this video. We're getting started. Okay, let's take a quick look at the scene. There is nothing complicated about it. We have the background object storing the default UI sprites. I just changed its color. There are 3 pedestal objects in the scene. Each pedestal is an object of image type and has the pedestal script on it. The animator component manages very simple clips. The first one is the scale up clip and the second one is the scale down clip. Unity plays the scale up clip when a player clicks on a pedestal object. At the same time, all remaining pedestals return to their original sizes. The scale down clip just decreases the value of the scale property of the pedestal object. Each pedestal has a child object of image type. These are hero prefabs. Each hero prefab has the image and animator component on it. The source image stores the sprite of a hero, and the animator component stores only one clip. It is the idle clip. Let me hit play. As you can see, everything is as simple as possible. All sprites and prefabs are stored in the assets folder. I will not focus on the animations in this video, I have added them just to visualize the player's actions. Okay, the hero data object stores a bunch of text mesh pro objects representing the character attributes like max health, current health, and the amount of damage that hero can do. These are typical hero's attributes for any game. All values are individual for each hero, and I hope when a player picks a hero, Unity will display those individual values. The frame object renders the yellow frame, and its child object hopefully will render the image of a picked hero. Okay, what do I want to get as a result? A player will pick a hero, and I want to send the picked hero's attributes to another object or scene. Well, it means that I need a good way of storing data. There are several ways to store data in Unity. They are all used for different purposes. One of the options for saving data is the concept of scriptable objects. Okay, what is a scriptable object? Scriptable object, according to Unity, is an inheritable class that allows you to store large quantities of shared data, independent from script instances. So, scriptable object is a container like any other class, but it is independent of script instances. What does it mean? When we create a script in Unity, by default it derives from monoBehavior class. To make monoBehaviors work, we have to attach them to one of the objects in the scene or one of the prefabs stored in the assets folder. MonoBehaviors become components of the objects, and only after that we can do with them whatever we need. Scriptable objects cannot be added to a game object as a component, but we can refer to them like we are referring to, for example, sprites when we create an object of image type. It is like an asset that can either hold data or execute code. Let's see it in action. I'm going to create a scriptable object. First, let me create a folder inside the scripts folder and name it Scriptable Objects. Now I will create a new C# script and call it Character Attributes. Open the script. By default, the class inherits from MonoBehavior. Let me change it to inherit from ScriptableObject class. This script is not gonna be sitting on another object as a component. Okay, we have created a class, but we haven't created an asset yet. To create an asset, I should add create asset menu attribute. This expression will give the ability to create a scriptable object in the editor menu. This is the easiest way to create a scriptable object. File name is the name of the asset we're gonna create. In this case, it will be hero attributes. It will be the default name. Menu name is the submenu name created in the editor. Okay, open Unity, go to the Assets menu. Here, click on Create, and we can see the name we have just given to the submenu. Click on it, and here it is. We have created the scriptable object. Call it Night. The object's label is different from other objects. We'll see that it is a scriptable object. At this moment, the object is empty. We don't see anything in the inspector. Back to the script. Let's add some attributes. The first one will be of string type. It's gonna be a name of a hero. And I'm gonna add 3 variables of integer type just to pretend that our hero has some characteristics. The variable of sprite type will store the sprite of a hero, and the variable of image type will store the prefab of a hero. I haven't added any script to the hero prefab, so let's refer to the image component. All variables are public. I haven't used properties, just trying to avoid diving into another topic that is not directly related to the topic of this video. Open Unity and select the scriptable object. We can see all the fields we have created. We didn't do anything special, we can do all this in MonoBehaviors. Let's fill those fields. The night is for the name field. Add random integers to fields of integer type. Let me add the sprite and the night prefab to the corresponding fields. Good. We have 2 more heroes. Let me just duplicate the scriptable objects. Rename them. Let's call them Warrior and Pirate. And let me change the values of the fields. Good. Now each scriptable object stores heroes' attributes. Fields are shared, but the values are different for each object. It's time to figure out how we can display the data. What I'm gonna do? The first step is to activate the scale up clip when a player clicks on the pedestal objects. At the same time, I have to activate the scale down clip for all other pedestals. The second step is to transfer picked heroes' attributes to the frame objects. Thus, we're gonna display heroes' attributes. It sounds like an interesting task. Let's go for it. Let's have a look at the pedestals objects. It has the hero data display script attached to it. It is always a problem to find the right name for the behavior the script is responsible for. Okay, never mind. As you can see, the script already has some fields. These fields store objects where we're gonna display the hero's attributes. And the pedestals object is the parent object for each object of pedestal type. Let's have a look at the pedestal object. It has the pedestal scripts and 2 clips managed by the animator. Okay, open the pedestal scripts. I have already added some fields and methods. The variable of the animator type allows us to access the animator component. The field is serialized, so I need to drag the animator component to this field. The character variable is the reference to the hero's attributes stored by the scriptable object. And I have created 2 methods. The first one activates the scale up clip and the second one activates the scale down clip. Very simple. Before scaling up, I have to scale down all other pedestals. To do this, I have called the scale all pedestals down method, which is a member of the hero data displayer class. Let's open it. The scale all pedestals down method, looping through the all pedestals array, starts playing the scale down clip. I have used the for each loop here just to simplify the code. Actually, it is better to use the observer pattern here. At the end of the video, for inquiring minds, I'm gonna show you how to create almost the same behavior, but using delegates. Why it is a bit better? Well, the for each loop calls the scale down clip for all pedestals, including those that are actually shouldn't be rescaled, since they're already scaled down when a player clicks on the pedestal object. It is extra work. We have only 3 pedestals, so it is not a big problem, but imagine you have inventory with hundreds of items in it. In this case, we definitely should rescale only one pedestal. It is the pedestal that was picked by a player. But again, let me just make it simple to focus on the scriptable objects, and at the end of the video I will show you another solution that I believe is a bit more professional. Okay, I guess it's time to drag objects to the fields we have created to see if Unity will play animation clips correctly. Okay, open the pedestal prefab and drag the animator component to the animator field. I have already set up transitions between clips. The isPicked boolean will help to switch between clips. I have added the button component to register players' clicks. So when a player clicks on the pedestal object, I'm gonna call the scale pedestal up method. Here it is. Okay, now let's place our characters. We have 3 scriptable objects and we created the character field of the character attribute type. Just add scriptable objects to each pedestal object. Good. Select the pedestal object. I have already dragged the Text Mesh Pro and image objects where we are gonna display the hero's data. But I need to add the pedestal objects to the all pedestals array. Let me do it. Good. We're ready to hit play. And click on one of the pedestal objects. Click on another one. Good. Unity has played the animation clips. It remains to display the hero's data and finally use a scriptable object. Now I need to transfer the hero's attributes to the frame objects. Back to the hero data displayer script. Let me activate one more method. It has only one parameter of character attributes type. This class is derived from the scriptable objects. Let me assign values stored in the scriptable object to the text and image objects. The max health is of integer type, so I need to convert it to string, calling the toString method. Thus, objects stored in the hero data displayer class will get values and sprites correspondingly. We haven't called the method yet. It is public, so I can access it from another class. Open the pedestal class. Let's call the methods we have just created right here inside the scale pedestal up method. Unity calls this method when a player picks a hero. Okay, let's see how it goes. Open Unity, hit play, and click on the pedestal object. Good. Unity displays the data that belongs to the hero picked by a player. The frame object has no idea what the hero object is. We have created references using the scriptable objects. Assets stored in the asset folder. There is no reference to the game object placed in the scene. Cool. The last thing to do is to send the selected hero to the battlefield. Let's have a look at the fight button. The button has the button component and the start fight scripts attached to it. So how to let the other scene know which hero was chosen? We don't want to use singletons, prefabs or players prefs class to save players' actions. Let's create one more scriptable object. Create a script, call it current progress and open it. Let's make it derived from the scriptable objects. And let me add the asset menu attribute. Well, if the name of the class will match the file name, there is no need to add the file name here. And I'm gonna add only one variable of character attributes type. Call it picked hero. It's gonna be public. Please don't tell a code reviewer that I haven't used the properties here. So this field will store another scriptable object, and this object stores hero's attributes, including its prefab. The idea is very simple. After we load the battle scene, we'll just refer to the scriptable object to get the prefab of a hero object. Open the hero data displayer script. Let me add the variable of current progress type, and let me assign the picked hero to it. I'm gonna do it inside the display hero data methods. So when a player picks a hero, Unity will save the player's choice in the current progress object. And having loaded a new scene, we are gonna refer to these assets. Let me also make sure that when we open the scene, the player's choice field doesn't store any objects. I'm gonna make it equal to null inside the start method. It is important since scriptable objects save the changes made in the play mode. We're gonna talk about it in a bit. Now open Unity. Let's create an asset. Let it be current progress. Drag the current progress object to the fields. Now let's have a look at the scene we're going to load. Let me open it. It is also a very simple scene. Again, we have a background object storing the default UI sprite. Hero position object is the position where we're gonna instantiate our hero. It has the hero deployer scripts attached to it. And the troll object is gonna be our enemy. It is animated. The animator component refers to only one clip. It is the attack clip. When a hero appears, the troll immediately attacks a hero, dealing some damage. Okay, let's open the hero deployer script. This script doesn't do anything special. First, it instantiates a hero picked by a player. To instantiate a hero, the instantiateFighter method refers to the scriptable object we have created. The current progress class stores the scriptable object of a hero, and we just need to find the prefab of a hero object. The prefab has no scripts on it, so I'm gonna instantiate a hero object as an image object. The last line of the instantiateFighter method places the hero at the coordinates of this object, which is the hero position object. Before I activate the remaining lines, let's see how it goes. Open Unity, make sure that you have dragged the current progress object to the player's progress fields. It is important. To make it work, I need to set up the build settings. Go to File, Build Settings, and here we can see our scenes in the Scenes in Build window. If you don't see them, open the Scenes folder and just drag scenes in. The battle scene has an index of 0, the hero bar has an index equal to 1. Referring to those indexes, we can load the corresponding scene. And back to the hero bar scene. Okay, the last step, open the start fight script. I'm gonna add only one method, call it load battle scene. This method, calling the load scene method, switches the Unity to another scene. The first parameter is the scene index. In our case, it must be equal to 0. And the second parameter just says that we don't want to have two scenes open. Unity should close the first scene and open another one instead. I have added the reference to the picked hero field just to check if a player has picked a hero. If a player hasn't yet picked a hero, then the button will not work. If the picked hero field is not null, Unity loads the battle scene. Okay, back to Unity, make sure that start fight button calls the load battle scene methods when on-click event occurs. Drag the scriptable object to the field. Okay, hit play, pick a hero and click on the start fight button. Unity loads the battle scene and we see our hero. Troll attacks, but nothing else happens yet. Let's see if Unity can save the current state of our hero. Let the troll deal some damage. Open the troll scripts. Some lines are already active. These lines just force the troll to attack, activating the attack animation clip, nothing else. Let me enable the damage variable and add the deals damage method. The damage is equal to 15, it's gonna be the argument passed to the hero takes damage method. The deals damage method calls another method, which is a member of the hero deployer class. Unity will call the deals damage method at the end of the attack animation clip. Well, the takes damage method is disabled so far, but we are gonna enable it in a bit. And let me enable the reference to the hero deployer class to make it work. Okay, open the hero deployer class and let me enable the hero takes damage methods. I need to decrease the current health of our hero. Referring to the scriptable object, I'm subtracting the amount of damage. Very simple. After the damage is done, we are gonna go back to the previous scene. Let's see if the value of the current health has changed. Let me add one more method just to load the hero bar scene. Its index must be 1. Call the method after a hero takes damage. Okay, open Unity. Let me add the deals damage method to the timeline. Select the troll object, add an event, and here it is. Okay, let me save the scene and back to the hero bar scene. Hit play, pick a hero and go to the battle scene. Okay, we came back to the hero bar scene, picked the same hero, and we see that the current health has been changed. Cool. If I exit the play mode and select the hero's scriptable object, I will see that the current health is still less than the max health. And this is the second important difference between the scriptable objects and simple mono behaviors. Scriptable object saves and stores all changes that happen during the runtime. It's very handy when you try to test your game. It allows you to see problems without playing the scene from start to finish. Instead of a hero, it may be an inventory system or anything you need to pick and send to another scene or object or to share data. Okay, to resume, there is no need to attach scriptable objects to the game objects. They can be stored as assets in the project. Scriptable objects can have almost all the methods that mono behaviors have. We cannot add the start and update method to the scriptable objects, but there is no real need for them since we cannot attach the scriptable object to an object placed in the scene. Okay, the last part of this video might be a bit excessive for the beginners, but I have promised to show the way we can optimize our code using the observer pattern. Let's see how it works. Open the hero data displayer script. I'm gonna add 2 fields to be able to implement the observer pattern. And I'm gonna modify the scale all pedestals down methods. Let me deactivate the for each loop. To add the line, I need to add a parameter to the method. It's gonna be of pedestal type. The idea is to assign to the delegate the scale down method that belongs to the clicked pedestal object only. Thus, we're gonna avoid extra work and there will be only one observer assigned to the delegates. It's gonna be the scale down method that belongs to the clicked instance of the pedestal class. So the last line assigns the scale down method to the delegate referring to the clicked pedestal. The if statement here checks if there is a method assigned to the delegate. When we run the play mode, all the pedestals are in their original state. And when the player clicks on the pedestal for the first time, there are no methods assigned to the delegate. If there are no methods assigned to the delegate and we try to call it, then C# throws a null reference error. The code block of the if statement calls all methods assigned to the delegate. We have added an observer to the onClick on next hero event, so we need to remove this observer after it does its work. I will add the clear delegate method that just assigns null to the delegate. Okay, when we should call it? Actually, we are gonna call it twice, right after the delegate has been called, and when a player clicks on the Start Fight button. Open the Pedestal class. Let's have a look at the scale pedestal up method. Let me add an argument to the scale all pedestals down methods. The argument refers to this instance of the pedestal class. Go to the Start Fight class. When a player goes to the battle scene, we should clear the delegate as well. To call the clear delegates method, I have created the reference to the hero data displayer class. It is a private serialized field, so I will need to add a pedestals object to this field. Okay, let's do it. Open Unity, select the Start Fight button and add the pedestals object to the all pedestals field. Good, hit play, pick a hero. Let's pick another one. It works perfectly, and let me hit the Start Fight button. Okay, a hero takes damage and Unity loads the hero bar scene. I can continue picking a hero. Cool. I hope you enjoyed this video. Thanks for watching.